This is the lecture for William Lane Craig's article, The Kalam Cosmological Argument. So the first topic is, uh, I don't know, like this, everything we read in this class is difficult. Philosophy is always difficult. Um, I don't know. My sense is maybe this article is a little harder than much of the other stuff we've read, but I don't know if that's actually true. It might just be that the way Craig writes is kind of more difficult for me than some of the other people, but that might just be me. That might not be you. So I don't know. I'm interested in whether people find this particularly difficult or not. Certainly, one thing about this article that it's true of some articles we read and not of other articles we read. This one has like a lot of stuff. There's like a lot of topics in this one. So, and he writes very densely, like he sort of, covers one topic in a short amount of space and then moves on to another. So that might make it uh, particularly difficult. But just, pay attention, read slowly, read things multiple times. So the next topic is deductive and inductive arguments. So we ended up covering this 2 weeks ago in class, but in case you were not in class, uh, he mentions them. Uh, so he described the Kalam cosmological argument as Al-Ghazali formulated it, every being which begins blah, blah, blah. He says, we shouldn't stumble at Ghazali's deductive formulation of the argument. The evidence needn't render a deductive argument's premises certain in order for the argument to be cogent. But if one prefers, the argument can be formulated inductively as an inference to the best explanation. So just briefly, deductive and inductive arguments. So a deductive argument is one where if the premises are true, then the conclusion must be true. It's sort of guaranteed to be true. So a deductive argument, if it's correct, it gives you like a guarantee that the argument, that the conclusion of the argument is true. An inductive argument is an argument that the conclusion is likely or probable. So with an inductive argument, if the premises are true, then the conclusion is likely true or more probably true than if the premises were false. So a deductive argument is an argument that establishes something with certainty if the argument works. And the, the, uh, the inductive argument is one that establishes something is likely if the argument works. Um, and then I don't know. You can figure out what Craig means by this sentence just with those definitions, I believe. One thing he says is you can formulate this argument inductively as an inference to the best explanation, and so that's our next topic. So what is an inference to the best explanation? So the form of an argument that's an inference to the best explanation basically says, here's a bunch of stuff. The best explanation of this stuff would be this claim. So this claim is true, or this claim is likely true. So, for instance, if you see a bunch of smoke off in the distance, what should you infer? Well, it depends, but like maybe the best inference in a lot of cases is, oh, there's a fire over there. Why? Well, because the best explanation for there being smoke off in the distance is that something is burning off in the distance. There are, of course, other possible explanations. Maybe someone has hooked up a smoke machine, or maybe somebody slipped you a drug and it's causing you to hallucinate smoke, or something like that. There are other explanations, but the best explanation is, look, something's on fire over there. So that's an inference to the best explanation. You're inferring the best explanation, the fact that there's a fire, from the evidence available to you. And so a lot of inductive arguments are inferences to the best explanation. They say, look, here's a bunch of evidence. The best explanation of this is something, and so that something is likely to be correct. One of the big debates in this paper is about A theory and B theory of time. Or I say it's a big debate. Actually, Craig says like this is important to the debate, but we're going to move past it very quickly. And he just discusses them. And so this is just to explain what those two theories are. So as Craig puts it, on a tensed or so-called A theory of time, temporal becoming is an objective feature of reality. Whereas on a tenseless or a B theory of time, all events are equally real, and temporal becoming is an illusion. So start with a theory of time, which is, I don't know, maybe the more intuitive one. Like maybe you are sort of already an a theorist without knowing it. I don't know. Like we can talk about it, but like a theory of time says there is the present, there is the past, and there is the future. And so this is called a tensed theory of time because we have like past tense for talking about things that happened in the past, present tense for talking about things that happened in the present, and future tense for talking about things that will happen in the future. And so notice future things have not happened yet. They sort of don't exist yet. They will eventually exist. Past things don't exist anymore. They happened in the past. The present things are the things that exist right now. And so there's the past, the present, and the future. And the present is kind of always moving. The present doesn't stay the same all the time. And so, according to a theory of time, that's how things work. Some things are in the past, they're not here anymore. Some things are in the present, they're here, and some things are in the future, they don't exist yet. That's as opposed to the B theory of time. So as he puts it, all events are equally real and temporal becoming is an illusion. So the B theory of time says there are there are things before things and there are things after things. So right now there's a lot of stuff. So look around and there's my hands and whatever. And there are things that are before these things. So there's lots of stuff that occurred before what's going on right now. And there's lots of stuff after these things. So there's lots of stuff that occurs after what's going on right now. And all of those are sort of equally real. There's no sort of special present that exists, whereas the past and future do not exist. These are the past, the present, and the future. Probably we shouldn't even speak of past, present, or future. We should just speak of like things. And some things are before certain things, and some things are after certain things. So there's lots of stuff after right now, and there's lots of stuff before right now. There's lots of stuff after tomorrow. There's lots of stuff before tomorrow. So you can order everything in the universe according to, its location in time compared to other stuff. But there's no past, present, and future, so to speak. Uh, you know, right now is like isn't special. Like the present is not some special time. There's lots of different times, and there are things before those times and after those times, and the whole thing exists at once. So on the B theory of time, it's kind of an illusion that we're like moving through time, like there's a special present, and the present keeps changing, and stuff goes in the past and stuff goes in the future. No, everything in the B theory of time is already laid out, and there's stuff before and stuff after. There's stuff before some stuff and stuff after other stuff. It just, pick any time in B theory of time, and there's before and after, and that time you pick is the present. But that the present is not especially real or anything like that. So those are theories of time. He briefly touches on the idea of mathematical realism or mathematical anti-realism, also known as nominalism, versus Platonism or realism. And this is about mathematical objects. So basically, this is a debate about mathematical objects. So the simplest mathematical objects are numbers like 6, 7, 12, 28, 14, 5. There's lots of numbers. So here's a good philosophical question. What's a number? Yeah, so that turns out to be kind of a really interesting question. And so two kinds of views you could have about numbers are the anti-realist views and the realist views. So the anti-realist views basically say there's not any such thing as numbers, or well, yeah, that's good enough. Numbers don't really exist. There's not actually like a 7 or a 5. Maybe these are labels that we use to talk about things that these are like fictional terms that we made up or something like this. They basically, I don't know, anti-realism gets more complicated and sophisticated, but that's the basic idea, and it's easily seen by contrasting it with realism, also known as Platonism, about numbers. So Platonism says there are things that are numbers. There are objects that are numbers. So like there is 7. 7 is an object. or 12 is an object. Usually they don't mean physical objects. It's not like 7 is like over there or something you can't go touch. 7, usually they mean they're metaphysical objects, so they don't exist in space or time, but they're still things in a certain sense. Um, and that's what numbers are. And again, this also gets more sophisticated. There's lots of stuff to say, blah, blah, blah. But this is just to sort of describe those kinds of views, just so you know what he's talking about. Also on 391, he mentions the famous Hilbert's Hotel, which is able to accommodate infinitely more guests despite its being fully occupied. So just so you know what Hilbert's Hotel is, Hilbert's Hotel is an infinitely large hotel. So it has an infinite number of rooms. So it has room 1, room 2, room 3, room 4, up through infinity. And all the rooms are occupied. So there's a person in every single room. And now somebody shows up to the hotel and asks, I would like to check in. Do you have any vacancies? And so the question is, can we accommodate this person in Hilbert's Hotel? And you might initially think, no, it's full. There's somebody in every room. But actually, no, because it's an infinite hotel, we can squeeze them in. So you say, okay, put them in an empty room. But where is the empty room? You can't go to the end of the hallway or whatever. You can't walk past all the filled rooms. You can't walk past room 1, room 2, room 3, room 4. So you can't just go to the end and go into an empty room at the end. Because again, they're all full. And also, you can't get to the end. It's infinite. So how are we going to fit this person in? Well, you just ask everybody to shift down a room. So you ask the person in room 1 to move to room 2. You ask the person in room 2 to move to room 3, etc. So then you clear up a space at the beginning for somebody to move into Hilbert's Hotel. And you think, great. But then the problem is now an infinite number of guests show up and they say, hey, can we check into the hotel? And now again, you have a puzzle. Well, there's no empty rooms, so it seems like there's no place to put them. But also it's an infinite hotel, so like surely you've got to have space to put them in. So you think, oh, maybe I can do the same trick. Maybe I can ask everybody to move down. But actually, I have an infinite number of people I need to fit. So can I ask the person in room 1 to move down an infinite number of rooms? No, they're never going to finish. That's going to take forever. So it looks like you're in deep trouble. How are you going to clear up an infinite number of rooms for these infinite number of guests? Well, the answer is you ask each guest to move into their room multiplied by 2. So you ask the guest in room 1 to move to room 2. You ask the guest in room 2 to move to room 4. You ask the guest in room 4 to move to room 8, etc. And this will clear up an infinite number of rooms for your infinite number of guests. So that's Hilbert's Hotel. On page 394, we see this symbol, which potentially you can't even pronounce, let alone understand. So this is Aleph null, or Aleph 0. I think it has other names too, but like this letter is Aleph. It's from the Hebrew alphabet, and then it's a 0 or a null following it. And so this is just the symbol for infinity, and specifically like countable infinity. And what that means is infinity in the sense of like the natural numbers are infinite. So there's like 1, 2, 3, 4, 5, 6, 7. There's like infinite number of those numbers, but you can count all of them. So it's not like it's an uncountable infinity. What that means, we don't really have to care about. But the thought is that Aleph 0 refers to that kind of infinity. That's how many rooms are in Hilbert's Hotel and things like this. On 395, he talks about the idea of an illicit modal operator shift. I don't know. You kind of don't really have to understand this. You never have to understand everything in an article. So this is maybe one of the things you don't understand. But like to briefly explain at least some of the relevant concepts. So a modal, actually, before we get to modal operators, just think about like modality. So modality is a special philosophical word that we use to talk about sort of possibility and necessity and actuality and stuff. Like these are sort of forms of modality. So they just have to do with like what could be, possibility, what could happen, what could exist, or necessity, what must be, if it's necessarily the case that I have 5 fingers, that's a fact about modality. If it's possibly the case that I have 5 fingers, maybe I have 5 fingers, or maybe I could have had 4 or 3 or something, then that's a fact about modality. So modality is just having to do with this sort of stuff, possibility and necessity and actuality. A modal operator is just like sometimes when we want to like write down stuff in philosophy, we come up with like symbolism to help us write things down. And so we have various symbols for describing modality. And specifically, you can see one of them down here. This is a diamond. This means possibility. And I don't have the other symbol, but the other symbol is a square, and this means necessity. So these are just modal operators. It's called an operator because that's the name we give to like when writing logic. It's a thing that does some sort of function. So this is a modal operator. It sort of operates on the thing that comes after it, and it says, oh, possibly g sub x. So, or g of x. So, you know, you can imagine writing like so you wouldn't really do this, but like if you wanted to, you could use a modal operator like this. Possibly it is Tuesday. So that's just what modal operators are. They're just little symbols that tell us about modality. And when he says, Cohen's objection involves an illicit modal operator shift, what he means is, oh, we're shifting at some point from like possibility to necessity, or from necessity to possibility, or something like this. And in fact, there's this footnote or endnote 24. And if you go to that, you get down to this. And oh, actually, sorry, there's another kind of modal operator shift, which is just like, oh, you go from possibly one thing to like possibly 6 things, but you're not allowed to do that. Or I don't know, something about it is illicit. Something goes wrong somewhere. That's just what it means for an illicit modal operator shift. Someone has just like done something with modality and something is wrong with it. And here he gives us what he thinks is the illicit modal operator shift, sort of going from this diamond GA and diamond GB and diamond GC and etc., going from that to this diamond GA and GB and GC, and he thinks that's an illicit modal operator shift. So that's just to explain what he means by modal operator shifts. Well, we're going to come back to this when we get to the end of the lecture. He doesn't say this out loud, but you may notice when you get to 398 and he starts talking about these things, and in fact, these are maybe super tasks, which we're going to talk about in a moment in the lecture. But once he talks about this stuff with like the Grim Reaper paradox on 398, you may recognize this is very similar to Achilles and the tortoise, not the version about logic that we read in the Carroll article, but the Zeno's paradox that Carroll was referencing in Achilles and the tortoise. So the idea that, Achilles and the tortoise are racing and the tortoise runs ahead, and then Achilles catches up with the tortoise, but in that time, the tortoise has gone on a little bit further. That kind of paradox, that Achilles and the tortoise, the original paradox about motion, that comes up here. Again, he doesn't call out Achilles and the tortoise, but you'll notice it's in the background. On 400, he says, Cohen seems to have fallen into the same trap I did when I first formulated the Tristram-Shandy paradox. The situation he describes is impossible because the task he set is inherently paradoxical. So the Tristram... Oh, misspelled it. That's fine. The Tristram-Shandy paradox is, Tristram-Shandy is a guy, he sits down to write his autobiography, and he starts writing, and he writes about the first day of his life, and he looks back and he realizes it took him a year to write about the first day of his life. It took him that long to write the biography just for his first day. And he says, "Ooh, this is not going to work. I can't write my biography like this because, of course, uh, let's say he's like 30 years old or whatever. Just to write 30 years worth of stuff, you have to do 365 times 30. It's going to take a year for every day, and so it's going to take forever. So he's never going to finish his biography. Uh, but of course, that seems or sorry, and also he's going to live forever. So he's immortal. And so you think, okay, well, I guess I see how he can't finish his biography. It takes him a year to write down a day, but he's immortal. So just tell me, for every day in his life, surely he can spare a year to write the biography of that day because he's got infinite years to write it. So it seems paradoxical. Can he or can he not write his biography? What's going on? And this brings up the idea of a super task. A super task is something where you have to accomplish sort of infinitely many things in potentially like a finite time or maybe an infinite time, whatever. A super task is accomplishing an infinite number of things. And sort of throughout the article, not the whole thing, but some parts of it, we have sort of discussion of super tasks or potential super tasks. And in fact, Achilles and the tortoise is maybe a super task because the distance that actually, forget Achilles and the tortoise. There's another Zeno's paradox of motion, which is kind of similar to Achilles and the tortoise, which is the paradox of the arrow. So you fire an arrow at a target. Can the arrow ever hit the target? Well, no, because how much distance is there between the arrow and the target? Well, there's an infinite amount of distance because, however much you take like half the distance between the target and the arrow, and then you can take half of that and half of that and half of that and keep going and going. And you can always subdivide the distance even more. So it seems like there's an infinite number of distances. They're all like, they get very small very quickly, but there's an infinite number of them. So it's got to be infinite. So crossing that infinite distance seems like a super task. How are you going to do it in a finite amount of time? Great. On pages 400 through 402, he has some discussion of like science and what science has to say about the cosmological argument. So if you're interested, then you're interested. That's great. We're not. This is not a physics course, so we can't sort of go into a lot of depth on the science. I'm not going to be able. I'm not even qualified to tell you is what he says correct or incorrect. I don't know. I don't know anything about theoretical physics. So don't ignore this stuff, but don't don't make it the entire focus of your thoughts about this article. This is not the physics stuff is not the stuff to spend your most time trying to comprehend. Finally, you also don't have to understand footnote 24 and note 24. Again, you'll never understand everything in an article, so this is maybe just something to let go. But if you do want to understand it, and if you haven't been in a logic course, or even if you have, but you haven't done modal logic, just to help you a little bit with these symbols. In fact, this really doesn't matter. So you can stop watching, or yeah, you can stop watching now if you want. But if you're curious. So this upside down A followed by X, this means for all X. So for everything, and just give it a label X, f of X, the sideways U shape, diamond, G of X means if X is an F, so if it has this property of Fness, so let's say F stands for being on fire. If X is on fire, then possibly X has G, the property of G. Let's say it's green. So this means for every X, if X is on fire, then possibly X is green. So that's the sort of basic idea. This symbol in the middle, which I can't really highlight, it means like if then. So f of x, if f of x, then possibly g of x. And f and g are just labels for, so in here, f is a future object and g is presently created by God. So this means for every x, so basically for everything, because x could be anything. So for everything in the entire universe, if x is a future object, then it's possible that it's presently created by God. So that's what this says. And I think that's all you need. So you can see what you think about this argument if you can figure it out. Like, again, not a big deal.